And now we are going to talk about what is called straight line motion. Now, we're going to be talking today not about projectile motion. That's something we did a lot in Algebra 2, where we talked about something going up in the air and coming down. We're going to be talking about the motion of something going along a line, just back and forth, just crawling along a line, back and forth. This is called straight line motion because he's going back and forth. We're going to be analyzing an equation and then figuring out what exactly this little bug or this little particle is doing. But first, a few definitions. Please write down S of t. S parentheses t. Okay? S of t like f of x. We did this on the Calculus No Calculus Day. We introduced this. Whenever you see a function that is written like this, it is defining the position of a moving object. It is telling you the position, where it is on the number line that it's crawling across. Okay? And a lot of times they will refer to this moving object as a particle. A particle travels along the x-axis doing blah, blah, blah. I don't know why they say particle, they just do. Like an electron electrons don't go in straight lines, they go in our orbits, don't they? Yes. It's been a while since I took chemistry, I know. Okay, now, if you take the derivative of position, that means the rate of change of the position of something, and what is the physics term for that? Velocity. S prime of t is the same thing as v of t, which is the velocity of an object. Okay? You tell me, can velocity be negative? Why? Okay, downward because velocity includes the direction component, whether you're going up or down. Positive velocity usually means going up. Negative velocity means going down. But since we're going this way, which direction do you think? Right. To the right. And then negative is considered to the left. Okay? So, this can be negative. Okay? Now, the next one is the absolute value of the velocity. Speed. And that happens to be speed. Because speed is velocity when you don't take the direction into consideration. It is the speed of an object. And it is always positive. Okay? Let's say your car is sitting on a straight road. Nobody in either direction. You put your car in drive. You go forwards 20 miles an hour. Okay? You stop. You put it in reverse. You go backwards at 20 miles an hour. Your speed is 20 miles an hour. I don't care whether you're going forwards or backwards. Your speed is 20. Okay? 20 miles an hour. I don't care what direction you're going in. Now, the last one is the derivative of the velocity. One of my kids just blurted this out in first period. The rate of change of velocity is called the what? Acceleration. So this is also a of t, which is the acceleration of an object. So, S of t is position, v of t is velocity, a of t is acceleration. What's the relationship between S and a? It's the double prime, exactly. It's the double prime. Have a seat. All right. Now we're going to start the analysis process. Your homework tonight is 4 questions. But because it's 4 questions, what do you probably think about those questions?
They're so long and hard.
They are rather lengthy, I will tell you that. Now, this note is going to be doing one problem, but it's going to take a while because I'm going to be explaining as we go. So it's going to take quite a bit of paper. Just letting you know right now because of the explanation involved. Here is the position equation for a certain moving particle, 1/3 t to the third minus 3/2 t squared plus 2t. That is the function that defines the path, the straight line motion path of a moving particle. Okay? No, I've got notes up here. Okay. Now, each of my numbers, 1 through 4, is going to be denoting one of the things that you're going to be asked to do. We're going to be asked to create a series of number lines. And these number lines are analyzing how this little bug or particle is moving. I like to call them bugs because I think about a little bug crawling across an axis. Okay? The first thing you have to do is to find the velocity at any time t. Find the velocity at any time t. Okay. Let me change the question for just a minute. If I had said find the velocity at t equals 3, do you think your answer would be a number or an equation? If I said find the velocity at time 3, would the answer be a number or an equation? It would be a number. How fast is it going at time 3? It's only going a certain speed or a certain velocity. Okay, but this one says at any time t, which is a big hint that your answer will probably have t's in it. Because it says at any time t, it's going to be an equation. It's going to be a formula. Now, what do we do to this to find the velocity again? Take the derivative. So we're going to write v of t equals, take the derivative. What's it going to be? 1t squared minus 3t plus 2. Okay, there's velocity at any time t. So, because it says at any time t, my answer has t's in it. That makes sense. Okay, part B. Find when the particle is at rest. Period. Find when the particle is at rest.
That being 0.
What being 0? The velocity. Most everybody has already known that. When something's at rest, its velocity is 0. So what we're going to do is we're going to take the velocity and we're going to set it equal to 0. So anytime you see at rest, that means take the velocity, set it equal to 0. So t squared minus 3t plus 2 equals 0. How do you do that? Quadratic or? Let's factor. This one's an easy one to factor. You tell me, how does it factor? Minus 1 and minus 2. So I get t equals 1 equals 2. So this little moving particle only stops twice. At t equals 1 and t equals 2. Okay? Now, what the problem is going to ask you to do, this is the setup to get you ready for part 1, which is to make a or a velocity number line. We are going to make a direction number line. We're going to use this information to figure out what direction this thing is moving. Is it going right? Is it going left? Where is it turning around? Etc. Okay? Now, here's the way this works. Our number line is going to have a bracket on the left and go out to the right. The bracket is at 0. Why? Because we don't have negative time when we're talking about a moving object in this case. Time starts at 0. This is 1, 2, 3, 4, 5, 6, and so on. Okay? I'm going to write velocity here. And then down here I'm going to write direction in parentheses, and you'll see why in a minute. Because we talked about it a minute ago. When you're talking about up and down motion, velocity means up, negative velocity means down. But right and left, positive velocity means right, negative velocity means left. Okay? So, first thing you do, after you've found where the velocity is 0, you take these two numbers and put them on the number line. 1 goes there, 2 goes there. And above it, we're going to write what its velocity is at that point, which in this case it is 0. So, if these are the only two time stops, this thing has to be moving either left or right at first. Then it's got to be moving either left or right. Then it's got to be moving either left or right. So the velocity has to either be positive or negative, positive or negative, or positive or negative. So here's how we're going to find out what it's going to do. We're going to pick points between values on the number line. We're going to pick points between those values on the number line. and we're going to see what sign the velocity is. Okay? So we're going to find the velocity at some number between 0 and 1. What do you want to use? 0.5. That sounds good to me. Okay? Now, I want to see what sign the velocity is, so I'm going back up here to the velocity equation. It's easier to plug it into the factored one because I don't care what number it is, I just care what sign it is. Okay? So I'm going to take 0.5 and I'm going to plug it into the two factors one at a time. When I plug 0.5 in for t here, what sign will it be? It'll be negative. So I'm going to have a negative times another negative, which is a positive. So that tells me that in this area the velocity is going to be positive. Okay? Because these two parentheses are multiplied. Okay? Now, pick something between 1 and 2. 1.5. Substitute that into the factored velocity. What is it going to give you sign-wise in the first parentheses? Positive first. And then 1.5 minus 2 is a negative. Positive times a negative is a negative. Are they always going to alternate? No. You can't assume that if the first one's plus, the next one's going to be a minus. Sometimes it does, sometimes it doesn't. You've got to always check. Something past 2. 2.5 or 3. I'm going to do 3 because it's easier. I could do 20 if I wanted to. Okay, plug 3 into these two equations. The first one, 3 minus 1, that's positive. 3 minus 2, that's positive. Positive answer. Okay? So, the velocity is positive, then negative, then positive. What does this positive velocity mean about its direction? It is moving to the right. So I'm going to write the word right there. And then it's moving to the left, and then it's moving to the right. So if I asked you, can you name the interval on which it is moving to the left? Could you do that for me? 1, 2 in parentheses. It's moving to the left. Okay? That's what this is telling you. So, can you picture what's happening? This thing is moving to the right, then it's turning around and moving to the left, and it's turning back around and moving to the right again. So it's kind of making an S look. Okay. That's part 1. That's the longest one. Okay? The next 3 are short. Now, part 2, going to a new sheet of paper. We are going to make, you don't have to go to a new sheet, I did. Make an acceleration number line. Okay. The acceleration is the derivative of the what? The velocity. The derivative of the velocity. So let me pull the velocity and put it back up here so you can see it. Here's the velocity. Okay? I need to take the acceleration. So I'm going to take the derivative of the velocity. And what will that be? 2t minus 3. Well, that was easy. Okay. You're going to go through the same steps you just did on the velocity. So what was the first thing we did when we did the velocity problem? We set this equal to 0. So we want to know the rating. So we set this equal to 0 and solve for t. 2t equals 3. T equals 3/2. Okay, that's it. Then we made a number line using that answer. So that's what we're going to do again. So number line here, put the 3/2 on it. It's the only number besides the 0. We're going to label it acceleration. If you do not label these, you will not get full credit. They have to be labeled. We're going to use the same process again to see where the acceleration is positive and where it's negative. So I need a number between 0 and 3/2. 1 sounds like a great choice. Substitute 1 into the acceleration. What sign will it be? Negative. So that means that that's negative right there.
Now, do you
Question or
put
not?
into the original like a...
Yeah, you put it into the acceleration equation. Any version of it. So A, what's something bigger than 3/2? 2. When you plug in 2 to here, what sign do you get? Positive. So that's plus right there. Okay. Now, does that really mean anything like right and left? No, it doesn't. But it coupled with the velocity is going to mean something very, very important. Okay? So all we do for acceleration is that. We're done. Step 2's done.
Coupled with the velocity, that's speed,
Yes, that's what we're doing next. Okay, number 3, we are going to make a motion number line. Okay. I had some kids in first period a little confused about this, and I don't know if it was not taught yet or it was just a misunderstanding or if they just didn't hear it right from their teacher. But we need to define exactly what speeding up and slowing down have to do with velocity and acceleration. Okay? Does anybody think they know the definition of speeding up as far as velocity and acceleration go? Okay. I was under the misconception for a long time, because I didn't take physics, that speeding up meant the velocity, that the acceleration was positive. That's not what it means. Speeding up does not necessarily mean a positive acceleration. You have to look at both the velocity and the acceleration, and they have to be doing the same thing. The velocity and acceleration have to be the same sign in order to be speeding up. So this occurs when the velocity and acceleration are the same sign. They're helping each other out. So negative velocity and negative acceleration is speeding up. Okay? Slowing down occurs when velocity and acceleration are opposite signs. I just had an epiphany that I'm going to share with you. When we do the number line in just a minute, it's a good thing. If the signs are the same, it's either 2 positives or 2 negatives. When you multiply 2 positives or multiply 2 negatives, what do you get? A positive, speeding up. That's plus. When the signs are opposite, that's a positive and a negative. When you multiply those two, what do you always get? Negative. That's like slowing down. So look at the signs. If they're the same, think of if it's positive, that means they're speeding up. If they're negative, it's slowing down. That was it. Just the fact that you multiply the signs and it gives you speeding up versus slowing down. I had never said it that way before. Okay. Now, before you draw your number line, I need you to skip about 3 lines. Okay? So skip about 3 lines. Come down. I think that's going to be enough room. This is the motion number line. Okay. And what this is, the motion number line is basically merging the velocity and acceleration onto the same number line. Okay? So, this is where the colors come into play. I'm going to go up 2 lines and I'm going to write velocity right here. And on the next line down, I'm going to put acceleration. So we're going to merge our number lines into one. Okay? Still starts at 0. Now, the question is, what numbers do I put on here? There's no solving for anything. You've already done all the solving. The numbers that go on this number line are all of the numbers that you used on either the velocity or the acceleration. So let's go back and look. What did we use? We used 1 and 2 on the velocity, and we used 3/2 on the acceleration. So those are the numbers that go on here. I'm going to put 1, 3/2, and 2. So those are the 3 numbers that go on there. Just take all the numbers you've already used, put them on the number line. Okay? Now, we're going to do velocity first. So I'm going to take my velocity number line, which is right here, and I'm going to transfer its data onto here. This one says that from 0 to 1, I was positive. So from 0 to 1, I'm going to put a plus sign right there in red for mine. Then it says from 1 all the way to 2, I'm a minus sign. So notice there's a break in the middle. I want you to draw 2 separate minus signs, one for this section, one for that section. And then after the 2, it's positive again, so I'm going to put a plus sign right there. Is everybody understanding what I'm doing?
Not really. No.
Okay. I'm taking these plus and minus signs and transferring them up here.
Just from both of them?
Just the velocity one first. I'm going to do the acceleration one in a minute. So 0 to 1 was a plus. And then here 1 to 2 was a minus. So 1 to 3/2 is minus, 3/2 to 2 is minus, and then 2 on is a plus. So I transferred that data up there. Okay? Are we good now? Okay, next page. Now, here's the acceleration one. I need to transfer it as well. The acceleration one said that up to 3/2 it's minus. So that means this is a minus section, and so is that. And then after 3/2 it's pluses. So plus there and plus there. Are we good? Okay. Now, look down each section. You are now comparing the velocity and acceleration. So for this first section, speeding up or slowing down? That's slowing down. So we write slow down here. What's the next one? Speed up, because they're the same. The next one is slow down. And the next one is speed up again. You have now described the motion of this particle, where it's speeding up, where it's slowing down. Okay? Really wasn't any work there. It was just throwing it all in the same number line and analyzing it. Do you have any questions now? Okay, so we've taken velocity, looked at it, we've taken acceleration, we've put it all together in the motion, and now we have one more to do. We're going to actually graph out where this thing is traveling. Okay? And I don't have enough room to do it here, so I'm going to a new sheet of paper. Number 4. This is make a position number line. Okay. Now, we are actually going to plot the path of this moving particle. It is not an XY grid. It's just back and forth over time. Okay? So, in this case, the number line is not the times, it is where it is. Could this thing possibly travel into the negative number line? Could it? Yeah. So I'm not going to have a bracket on one end. This is going to just be a straight line. It's like a number line. Okay? Now, the question is, what numbers do I put on it? I put the numbers on that are straight off of the motion number line. What numbers did we use? 0, 1, 3, you have to use the 0 also. So we're going to find the position at 0, that's S of 0, S of 1, S of 3 halves, and S of 2, because remember, S is position. We haven't even used the position equation yet. We've always been using the velocity of the acceleration up to now. Okay? So now, this tells me where it is at 0, where it is at 1, and so on and so on. Now, that position equation was kind of long. Let me bring it back up here. That's it right there. You see it? Okay. I think I'm going to use a calculator to calculate these values just to make things go faster. So go ahead and get your calculator back out. Type that equation into y equals. I'll move this over just a little. We're going to go to y equals. And I need to go back to the old mode. So 1/3 x to the third minus 3 halves x squared plus 2x. And go ahead and graph it on Zoom 4. Okay. It's a weird graph. It's kind of a cubic looking. It's supposed to be a cubic thing. Okay. Now, why did I graph it? Well, I could have gone to the table to get these values, but 3 halves wouldn't have been on the table. So I'm going to go ahead and just trace and find them instead. Okay? So what I'm going to do, now that I have the graph, push trace and 0. Where am I? I'm at 0. Okay? Now you're already in trace mode, so just push 1 and enter. 0.83 repeating. Are any of you getting fractions for your y values? Yeah, sometimes it does that. That's okay. You can use fractions. 3 halves, 1.5. It's 0.75. 2 is 0.6 repeating, which is 2/3. So I just pushed the number and enter once I was in trace mode to get all those values. Those are the numbers that go on your number line, because those tell where he is. So I'm done with this. So I'm going to draw little braces here and say these go on the number line up there. All right. Now, I want them in numeric order. Not in the order that they're listed. I need them like a number line. So 0 is the smallest, so let's put 0 there. 0.6 is the next smallest, 0.6 repeating. Then 0.75, then 0.83 repeating. That's in numeric order, because this is a number line. We're just zooming in on part of it. Okay. Now, what we put here should match everything that we've done up to this point. Okay? So at time 0, it's at 0. So we're going to put a dot right at 0, go off to the side and put t equals 0. Okay? Then at time 1, it's all the way over at the other end at t equals 0.8, at s equals 0.83. So we're going to draw a line up, go over to here, put t equals 1 right there. Now, according to the velocity number line that we made right here, which direction was it supposed to go at first? It was supposed to go to the right. Did I go to the right? Yes, I did. I did. Let me move this down a little bit. Okay. Then at 3/2, it's supposed to be at 0.75. So that means he must have turned around and gone back to here. Here's t equals 3/2. Is that what he's doing now? Going to the left? Yes. And then at 2, he's at 0.6. So that means he's still going left. So t equals 2 is right there. He's at 0.6. Okay. Is that the end of the trip?
Yeah.
Because it didn't say it was only from 0 to 2. Which direction is he going to go now? How do you know? Because up here it says right, left, right, doesn't it? Doesn't it say that once he hits 2, he starts going to the right again? Yes. So, all I have to do now is swing around, go that way. Go to the right. Now, the reason we spiral upwards is because we can't go back and forth and really see what's happening. But what this is showing is that according to that equation, this little bug is moving all the way over here by the first time, then he turns around and goes back to here, then he turns around and keeps going that way forever. Right, then left, then right. That's what we drew. He doesn't go left again because he only stopped twice, didn't he? We found the velocity only stopped twice at 1 and 2. So now he's just going to go to the right forever and ever and ever and ever and ever and ever and ever. Okay? Question?